Welcome to the AP Precalculus course by Mathic Quest. Today, we will be solving questions based on 1.5 polynomial functions and complex zeros. You can download this quick revision sheet from the description below. Question 1. Find the degree, real zeros, and multiplicity of those zeros. First, f of x equals x times x plus 5 times x minus 3. Since the polynomial is in factored form, we can simply add the powers to get the degree. Here, x has a power of 1, x plus 5 has a power of 1, and x minus 3 has a power of 1. So that's 1 plus 1 plus 1, 3. Now to find the zeros, we will have to equate these individual terms to 0. So we get x equals 0, and its power is 1. So the multiplicity is 1. X plus 5 equals 0. That means x equals negative 5. So that's negative 5, and multiplicity is 1. And then finally, we have x minus 3 equals 0. So that's x equals 3, and again, the multiplicity here is 1. Second, it's again in factored form. So the degree is 4 plus 2 plus 3. That's 9. Equating them to 0, we get x equals 0 with a multiplicity of 4. 2x minus 1 equals 0. Add 1 on both sides, and then divide by 2. So that's x equals 1/2 with a multiplicity of 2. And then we have 3x plus 2 equals 0. Subtract 2 from both sides, and then divide by 3. So that's x equals negative 2 over 3, and the multiplicity is 3. Third, f of x equals x squared minus 64. Now here we have a quadratic, so we will have to factor it first. We can rewrite this as x squared minus 8 squared. And then, using the a squared minus b squared identity, we get x minus 8 and x plus 8. So the degree is 1 plus 1, 2. And the zeros are x equals 8 and x equals negative 8, both with a multiplicity of 1. Fourth, f of x equals x minus 1 whole cube. Now to factor these, we can either use splitting the middle term method or the quadratic formula. Here, negative 2 times negative 3 is positive 6, and negative 2 minus 3 is negative 5. So the factors are x minus 2 and x minus 3. And here, if we take positive 4 and negative 1, then their multiplication gives us negative 4, and adding them gives us positive 3. So that's x plus 4 and x minus 1. We have x minus 1 here as well as here. So that's 3 plus 1, 4. And then we have x minus 2, x minus 3, and x plus 4. So now the degree is 4 plus 1 plus 1 plus 1, that's 7. And the zeros are x equals 1 with a multiplicity of 4, x equals 2 with a multiplicity of 1, x equals 3 with a multiplicity of 1, x equals negative 4 with a multiplicity of 1. Question 2. Given one non-real zero of a polynomial, find its complex conjugate so that it is also a zero. First, 2 minus 3i. Now remember, to find complex conjugate, we keep the real number as it is and flip the sign of the complex number. So we keep positive 2 and change negative 3i to positive 3i. Second, here we will keep negative 7 and change positive 5i to negative 5i. Third, I plus 1 has a complex conjugate of negative I plus 1. And for 2i, the complex conjugate is negative 2i. Question 3. Determine the degree of the polynomial. Alright, so here we will use the difference method. Negative 7 minus negative 26 is 19. 0 minus negative 7 is 7. 1 minus 0 is 1. 2 minus 1 is 1. 9 minus 2 is 7, and 28 minus 9 is 19. Next, 7 minus 19 is negative 12. 1 minus 7 is negative 6. 1 minus 1 is 0. 7 minus 1 is 6, and 19 minus 7 is 12. Then we have negative 6 minus negative 12. That's 6. 0 minus negative 6 is 6. 6 minus 0 is 6. And then 12 minus 6 is again 6. Now, since all these numbers are same, we can stop here. And since the third difference is constant, therefore the degree is 3. Question 4. Let h of x be an odd function which is strictly increasing. Find a, b, and c. Since the function is odd, if we have x and y, then we definitely have a negative x and negative y. Now look here and here. This is positive 25, and this is negative 25. So if this is positive 8, then this must be negative 8. Similarly, if we compare these two, here we have negative 14, so this is positive 14. Therefore, if this is negative 6, then this must be positive 6. So a plus b will be negative 8 plus 6, so that's negative 2. And then finally, comparing these two, this is negative 2 and this is positive 2. So if this is negative 2, then this must be positive 2. So we got a equals negative 8, b equals 6, and c equals 2. Question 5. Below is a graph of an odd function on interval minus 7 less than or equal to x less than or equal to 0. Complete the graph on the interval 0 less than or equal to x less than or equal to 7. Since it's given that this is an odd function, we will apply the rule for symmetry across origin. That means if we have xy, then we also have negative x and negative y. This is negative 2 and negative 3. That means we also have 2 and 3. For negative 3 and 0, we have 3 and 0. For negative 4 and 5, we have 4 and negative 5. For negative 6 and 0, we have 6 and 0. And for negative 7 and negative 5, we have 7 and 5. Question 6. Below is a graph of an even function on interval minus 7 less than or equal to x less than or equal to 0. Complete the graph on the interval 0 less than or equal to x less than or equal to 7. Now this time we have an even function. So that means if we have x, y, then we also have negative x and y. So this is negative 2 and negative 5. That means we also have 2 and negative 5. For negative 3 and 0, we have 3 and 0. For negative 4 and 3, we have 4 and 3. And for negative 6 and 0, we have 6 and 0. Question 7. If all real zeros are given, find the number of non-real zeros the polynomial has. It means we are looking for imaginary zeros. So let's start with the first question. Here, the degree is 3. We have real zeros at x equals negative 5 with a multiplicity of 2, and x equals 2 with a multiplicity of 1. If we add up the multiplicity, we get 2 plus 1 equals 3, which is also the degree. That means here we do not have any non-real zeros. Next, the degree is given as 7. Again, the multiplicities add up to 7, so we do not have any non-real zeros. In the third question, the degree is 9. Addition of the multiplicities is just 3. That means this time we have 6 non-real zeros. That way, the total becomes 9. And in the last question, the degree is 35. Adding the multiplicities, we get 23. That means here we have 12 non-real zeros. That way, the total becomes 35. Question 8. For each polynomial function, find the intervals for the given condition. First, f of x equals x squared minus 9x plus 14 for f of x less than or equal to 0. Now to solve these type of questions, we use the sign chart. But to make a sign chart, we need the zeros of the function. So let's factorize this first. If we multiply -2 and -7, we get positive 14. And if we add them, we get -9. So that's the factored form. And now, if we equate them to 0, we get x minus 2 equals 0. That means x equals 2, and x minus 7 equals 0. So x equals 7. Now that we have the zeros, we can start with the sign chart. First, draw a number line and mark 2 and 7. At these points, the function is 0. Because of these two zeros, here we get three intervals, from -infinity to 2, from 2 to 7, and from 7 to positive infinity. Now we need to test each of these intervals. For the first interval, pick any number between -infinity and 2. So let's say 0. Now we put this in our function and try to find whether we get a negative value or a positive value. So 0 minus 2 is -2, 0 minus 7 is -7, and negative times negative is positive. That means in this interval, the function is positive. Now you can do the same thing for the rest of the intervals. But there's actually an easy way to decide the rest of the signs. You just need to remember that if the multiplicity is even, we keep the sign, and if the multiplicity is odd, we change the sign. Now we already know that this is positive. The multiplicity of 2 is 1. That means it's odd, so we change the sign. So here, the function is negative. And again at 7, the multiplicity is 1. That means it's odd, so we change the sign. So here, the function is positive. Now the question was to find the intervals where f of x is less than or equal to 0. So we want either 0 or less than 0. That means negative. So our answer will be from 2 to 7 with a closed bracket, because at 2 and 7 we get 0. Next, f of x equals x cubed minus 3x squared minus 10x for f of x greater than or equal to 0. If we take out the x, we will be left with x squared minus 3x minus 10. If we take -5 and positive 2, their multiplication will give us -10, and addition will give us -3. So the factors are x, x minus 5, and x plus 2. Equating them to 0, we get x equals 0, x equals 5, and x equals -2. Let's mark them on the number line. For the first interval, let's pick -3. We get -3, -3 minus 5. That's negative. And -3 plus 2 is again negative. Negative times negative is positive, and positive times negative is negative. So in this interval, the function is negative. Now here, 0, -2, and 5 all have multiplicity of 1, so all are odd. That means we will keep changing signs. So here we get a positive, then a negative, and then positive again. Now we want the function to be either 0 or greater than 0. That means positive. So here, the answer will be from -2 to 0, and from 5 to positive infinity. Now this one's easy, as it is already written in factored form. So we have x equals 0, x equals 3, x equals -2, and x equals -1. Let's put them on the number line. Now one thing to notice here is that these two factors have an even multiplicity. That means they do not contribute to sign change. The reason is, whenever we have even power, the result is always positive, and that's why it doesn't affect the final sign. So we will only consider x and x plus 2. Alright, for the first interval, let's select -3. So that's negative, and -3 plus 2 is again negative. So the function is positive. Alright, once we have this, we will decide the rest of the signs based on multiplicity. At -2, the multiplicity is 3, that's odd, so we will change the sign. At -1, the multiplicity is 2, that's even, so we keep the sign. At 0, the multiplicity is 1, that's odd, so we change the sign. And at 3, the multiplicity is 6, that's even, so we keep the sign. Now we want the function to be either 0 or less than 0, so that's here and here. So our answer will be from -2 to 0 and at 3. Question 9. Given the following functions, determine if the following functions are even, odd, or neither. First, y equals g of x plus k of x. Let's name this function p of x. G of x is x cubed minus 5x, and k of x is x to the power of 5 minus x. If we add them, we get x to the power of 5 plus x cubed minus 6x. Now, if we substitute x with negative x, we get p of negative x equals negative x to the power of 5 plus negative x to the power of 3 minus 6 times negative x. So that's negative x to the power of 5 minus x cubed plus 6x. Notice how all signs are flipped if we compare with p of x. If we take the negative sign outside, we get x to the power of 5 plus x cubed minus 6x. This is exactly what p of x was. So that means p of negative x is equal to negative p of x. Therefore, this is an odd function. Next, y equals h of x minus g of x. This time, let the function be q of x, and that's equal to 2x squared plus 5x minus x cubed minus 5x. Opening the brackets, we get 2x squared plus 5x minus x cubed plus 5x, which simplifies to negative x cubed plus 2x squared plus 10x. Q of negative x will be minus negative x cubed plus 2 times negative x squared plus 10 times negative x. That's x cubed plus 2x squared minus 10x. If we compare it with q of x, only some signs are flipped. That means this function is neither even nor odd. And then we have y equals f of x minus 2 times h of x plus 10x. If we assume that this function is r of x, then we get x to the power of 4 minus 2x squared minus 2 times 2x squared plus 5x plus 10x. That's x to the power of 4 minus 2x squared minus 4x squared minus 10x plus 10x, which simplifies to x to the power of 4 minus 6x squared. R of negative x will be negative x to the power of 4 minus 6 times negative x squared, which is equal to x to the power 4 minus 6x squared. This is exactly the same as r of x. Therefore, this is an even function.